Welcome to the second part of the tutorial session of the content that was covered in week 1. We had discussed about units and dimensions and scalars and vectors in the previous part of the tutorial. Here I will discuss about the statics, kinetics and kinematics and laws of motion. Some problem statements would be solved. Just to recall the basic theory or in statics, equilibrium of forces, sum of all the forces acting on a body must be 0 for the body to be in a static equilibrium. That means summation of all the forces should be equal to 0. Equilibrium of movements, sum of all movements about any point must be 0 for the body to be in static equilibrium. So that means sum of all the movements is also equal to 0. Moment of a force. The movement m of a force f about a point is product of the force and the perpendicular distance r from the point to the line of action of the force. That means movement is equal to force into r. These are certain principles that we discussed in the week 1. Simple relationships for the velocity, which is change in the position of the object, that is displacement per unit change in time. This is velocity, velocity of rate of change of displacement with respect to time. Similarly, acceleration a is equal to dv by dt, that is change in velocity per unit change in time. It is rate of change of velocity with respect to time. Then the equations of motion that we discussed. First equation of motion, that is v, that is final velocity, is equal to u plus at. Final velocity v is the sum of initial velocity and the product of the acceleration and time. Second equation of motion is s is equal to ut plus half at square, that is displacement s is the sum of the initial velocity into time plus half of the product of acceleration and the square of the time. Third equation of motion, that is v square is equal to u square plus 2as, that is square of the final velocity is equal to the square of the initial velocity plus twice the product of acceleration and displacement. These are general formulas that you had been reading in your senior secondary education as well, and these would be applied in engineering mechanics further. Then we had Newton's second law, that is force is equal to mass into acceleration, that is force acting on an object is equal to the mass of the object multiplied by its acceleration. Work energy principle, that is work is equal to delta k, that is work done in an object is equal to change in the kinetic energy. Then power is equal to change in the work per unit change in time, it is rate at which work is done over time. Now let us try to use these to solve some numerical questions. A 10 kg block is in equilibrium on a frictionless surface with forces F1 is equal to 20 Newton and F2. Find the magnitude and direction of F2. The body stays in equilibrium, that is the first principle of equilibrium that we saw. That means suppose this is a body, frictional surface is there, it is a 10 kg block, F1 force is 20 Newton, which will try to push this in this direction. To keep it in equilibrium, we have to find what will be the value of F2. Simply we know summation of all the force is equal to 0, that means F1 plus F2 is equal to 0. F1 is 20 Newton plus F2 is equal to 0, that means F2 is equal to minus 20 Newton, that is in the opposite direction. That means I have my force F2 here, if this is my F1 is equal to 20 Newton, F2 will be equal to minus of 20 Newton, right. So, this is a simple application of the equilibrium of forces principle to find the force acting in the opposite direction. So, there is a problem statement where it is mentioned a car with a mass of 500 kg is moving with a velocity of 10 meters per second. Calculate the kinetic energy. We all know there is a simple relation between kinetic energy and the mass and velocity. So, mass given is 500 kg and velocity given is 10 meters per second, very slow moving car. As now it is given, kinetic energy relationship we know is equal to half mv square, which is equal to half into mass into square of the velocity. Everything is given in SI units, meters per second. 10 square, this is equal to 25,000 joules. This is a very simple problem statement. I will give you another problem statement where you have a velocity of a tennis ball that is moving at 40 meters per second and kinetic energy is given 80 joules. Calculate the mass. Using the same relationship, kinetic energy is equal to half mv square, you need to find the mass of the tennis ball. This problem you solve by yourself, you will find the solution in the lecture notes. Another problem statement is on the rotation now, the angular velocity. A disk rotates with an angular acceleration of 2 radians per second. If the initial angular velocity is 3 radians per second, find the angular velocity after 4 seconds and angular displacement during this time. This is interesting. So, we have omega naught, that is the initial angular velocity is 3 radians per second. Angular acceleration, which is denoted by alpha, is equal to 2 radians per second square, and we have been given time is equal to 4 seconds. So, angular velocity is equal to omega is equal to, we use the similar relationship like V is equal to u plus at. This is omega is equal to omega naught plus alpha into t. Simply we have omega naught as 3 plus alpha is 2 into time is 4, which is equal to 11 radians per second angular velocity, right. Then I have angular displacement. Theta, this is equal to omega naught t plus half alpha t square. This is equal to 3 into 4 plus 1 by 2 into alpha is 2, t square is 4 square. This gives me 28 radians. That is angular displacement during this time is 28 radians. There is another problem statement. A box is sliding down a frictionless incline of 30 degrees. If the box starts from rest, find the velocity after 5 seconds. So, here incline angle theta is equal to 30 degrees and the box starts from rest. So, here we know acceleration, because the angle given is 30 degrees. This is a plane surface 30 degrees and this is a box that is sliding down this frictionless surface. So, acceleration is equal to A is equal to g sin theta. This is equal to 9.81 into sine of 30. This is equal to 9.81 into 1 by 2 is equal to around 4.905 meters per second square. Initial velocity u is equal to 0. Final velocity is to be found that is v is equal to u plus at. This is equal to initial velocity is 0, acceleration is 4.905 into time 5. This is equal to 24.525 meters per second. The velocity after 5 seconds is 24.525 meters per second. So, there are certain other problems that you can solve by yourself. Next topic is laws of motion, inertia and momentum. Certain relationships which were discussed. The first law of inertia, that the body at rest or in uniform motion will remain so unless acted upon by an external force, that is a force is equal to 0, that is v is constant. Second law that we have already taken in the previous slides as well, the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass, it is force into mass into acceleration. Third law of the motion given by Newton is of the equal and opposite reaction. That is, for every action there is an equal and opposite reaction, that is F12 is equal to minus of F21. Then we talked about the linear momentum, that is equal to P is equal to mass into velocity, the momentum. Units is kg into meter per second, mass into velocity. Impulse is J, that is change in momentum, which is also equal to force into change in time. So, there is a theorem known as impulse momentum theorem, that is force per unit change in time is equal to mass per unit change in velocity. Conservation of momentum, that is initial momentum and final momentum is same in a closed system with no external forces. Inertia. Moment of inertia, rotational analog of mass of linear motion, we know I is equal to mr square, units are kg into meter square. Rotational inertia tau is equal to I into alpha, that is torque is equal to the moment of inertia times the angular acceleration. Let us see a few numerical problems here. Find out how much net force will be needed to accelerate a 2500 kg truck at 5.5 meters per second square. So, we have to accelerate it to this level. So, we know here acceleration A is equal to 5.5 meter per second square and mass is given, that is 2500 kg. We need to find the force. Force is simple, mass into acceleration, that is 2500 into A, 5.5, that is equal to 13750 Newton. So, net force required or needed to acceleration a 2500 kg truck to an acceleration of 5.5 at an acceleration of 5.5 meter per second square is 13750 Newton. Let me try to see another example where a racing car driver is on a racetrack. In order to overtake, he accelerates his racing car first at the rate of 8 meters per second square, then at the rate of 16 meters per second square. Find the ratio of the forces exerted by the engine for the acceleration change. So, we need to find the ratio of the forces which it has exerted. So, it is simple ratio to be taken. So, we will just use a simple formula again, force is equal to mass into acceleration, that is force F1 is equal to mass 1 into acceleration 1 and force 2 is equal to mass 2 into acceleration 2. The mass is same all the time, the mass is m. So, we know A1, the initial acceleration here given is 8 meter per second square, and we know A2 is equal to 16 meters per second square. So, we have to find the ratio between F1 and F2. F1 by F2 is equal to MA1 by MA2, that is equal to A1 by A2. Simply we have A1 by A2 is equal to 8 by 16 is equal to 1 by 2. That means F1 ratio F2 is 1:2. So, ratio of the forces exerted by the engine is 1/2 for, that is we have taken or gotten result here. This is another example that is here. When a bullet of mass 20 gram is shot from a gun that has an initial velocity of 40 meters per second, the mass of the gun is 5 kg. What is the initial recoil velocity of the gun? So, it has been given the mass of the bullet as 20 grams. We have to convert this into kg, and we have been given the mass of the gun, that is 5 kg, right? And initial velocity is given for the bullet is 40 meters per second. Recoil velocity of the gun we have to take in. So, we will use the law of the conservation of momentum and try to solve this problem. You can solve it by yourself and try to find what is the initial recoil velocity of the gun. Try to solve it by yourself. Try to use the law of the conservation of momentum and get the solution. You will get the solution in the lecture notes, there you will find it, and this is for you as an home assignment. Another law of conservation of momentum problem here is, there are cars with masses 2 kg and 5 kg respectively. These are toy cars that are at rest. A car having mass 5 kg moves towards the east with a velocity of 5 meters per second. Find the velocity of the car with mass 2 kg with respect to ground. So, we have M1 as 2 kg and M2 as 5 kg. So, V1 is to be determined and V2, yeah, it is given 5 meters per second, V2 is equal to 5 meters per second. So, from the law of conservation of momentum, we know that the final momentum is equal to M1 V1 plus M2 V2. So, that is 2 kgs into V1 plus 5 kgs into V2, that is 5 meters per second. Also, we know that initial momentum is 0 because they were at rest here, it is given, the cars were at rest. We also know initial momentum is equal to final momentum, law of conservation of momentum once again. So, therefore, this 0 is equal to 2 kg into V1 plus 25 kg into meters per second. This gives me the value of V1 as 12.5 meters per second. This tutorial session had very trivial problems. Trivial problems means the problems that you have been studying in the first year engineering or maybe in your pre-engineering senior secondary education. In the forthcoming lectures, where we will talk about the tutorial sessions on the stress strain diagram, about the different mechanical components, clutches, brakes, belts, etc., that will be having application of all these laws that we have studied here. So, I will give you a sheet of the numerical problems and statements that you will also solve for your home assignment. With this, I am ending this lecture. Thank you.